We will begin here. Just so that everybody understands, NCSI is a platinum partner of Imperva. We specialize in designing and implementing data security systems. Joining me today is Lester John, Senior Sales Engineer from the Imperva Encapsula team. Encapsula is the flagship cloud-based security system in the Imperva portfolio. For those of you who are not familiar with Imperva, Imperva is the market leader in web application firewalls, database protection, and cloud access security. In fact, if you research Imperva, you'll find that Imperva holds the extremely rare position of being the only web application firewall company in the upper right-hand quadrant of the Gartner Magic Quadrant for web application firewalls, and has held that singular position now for 3 straight years. This is an unprecedented achievement in the IT industry. In addition to web application firewalls, Imperva is a market leader in distributed denial of service mitigation. I use the word mitigation rather than blocking, as you'll see a little bit later in the presentation. This is an educational presentation, not really a sales presentation. We want to talk about the ecosystem of DDoS attacks. We'll cover how to design protection and then cover the anatomy of attack by actually attacking a live website online. And I know it's a little risky. It's actually my website, so I imagine I'll probably hear from my security team while we're doing this. But I want to present to you Lester John. Lester, you should have the con, and take it away.
Good morning. My name is Lester John, as mentioned, and yes, we're going to be attacking our partner's website towards the end of this presentation. So really just quick overview on what the agenda is. As we mentioned, we're going to quick introductions. I think we've covered current DDoS environment, where is it going, DDoS mitigation architecture solutions, and then we're going to run into that simulation. And what we've done is we're using an off-the-shelf tool that's designed for this, and I've actually pointed you guys at a YouTube video that talks about the tool, using it against various platforms. So, current DDoS environment. There's 2 types of attacks, and I think the application attack hasn't gotten as much press as the volumetric attacks. The volumetric attacks are usually as big as 600 plus. There was a recent one last week against the security blog, and there were various others throughout the year against different media outlets, and I think those get press, but those are primarily volumetric network attacks, and they're really focused on the layer 3, 4, and they're using various devices on the internet to basically broadcast traffic to a single point or to a single network, and basically overrun that network's link or overrun those network routers. Now, one of the things I want to point out about volumetric attacks is we always focus on the megabits per second, and this is where it's changed a little bit over the course of the last 2 years. It's not so much about the megabits of the attack, it's more about the packets per second. And here's the thing, a large packet has the same size datagram that needs to be processed by the equipment in line on the way to the customer's premise equipment. If I can send fewer large packets, that device might be able to stand up to it. But if I start sending much smaller packets and many more of them, what we're starting to see is that the network equipment is not designed for that number of connection processes. So really what we've seen over the course of the last 2 years is not so much the size go up, but the packets per second go up. The second type of attack I want to talk about is application layer attack. Now, these have always been out there, but they haven't been as popular until we've really gotten into platforms like Microsoft, Amazon, and Google. These companies have huge amount of processing power. What they don't have, even with that processing power, is handling the complex applications. My favorite one that I like to talk to people about that's brought down a kitchen recipe site was the chicken attack. Now, I didn't know this, but chicken actually exists in a lot of recipes, more so than any other meat. So essentially what this application attack was it kept hitting the search of this website and requesting recipes with chicken. So as strange as it sounds, the application on its own started to take itself down. So it doesn't necessarily need a huge volume of these type of attacks. It just needs the proper target to force all of the back-end systems to basically start attempting to process it. As technology has progressed and as more people move into the cloud and more people move into application as a service, we've seen a huge rise in application layer attacks. The attack we're going to simulate today is an application layer attack. So let's kind of talk about the trends. So I don't have the 2015 slide up, but in 2015, we basically saw the attack sizes go up by about 100 plus megabits per second. This year, the megabits per second have started, the megabits per second have started to drop, but what's increased, as I mentioned, are the packets per second, but the attacks are getting larger. So this year, the largest attack, and I apologize, this slide was prepared prior to last week's. The largest attack seen was about 470 gigabits per second. We'll probably be revising this in about another month once the final total comes in on that last attack, but we believe that attack was north of 650. So they are getting larger, and part of the reason they were able to do that was the Internet of Things. And if you think about the number of devices currently connected in your home versus the number of devices that were connected in your home 5 years ago, that's increased, and now all of those devices can be used in a variety of attacks. So a little bit more about the trending. I'm kind of going to let that slide just sit for itself. So let's talk about architectures. There are many different types of architectures, and one of the things we've done, and one of the things that's probably kept us in the Magic Quadrant for the last 3 years, is there's what's referred to as scrubbing centers. Scrubbing centers, most companies have 1 or 2, maybe sometimes 3 or 4 in region, and when a customer gets under an attack via BGP or some other type of routing mechanism, they're going to attempt to move your traffic from wherever it's coming to one of those points of presence. It's a great solution. It's the way traditional DDoS vendors, both blocking and mitigation vendors, have built their platforms. What we found is that it's not as effective as these attacks have ramped up. So what we've done is every single point of presence for the Imperva encapsula solution is a scrubbing center. Okay, I've got a message. We're experiencing difficulty with the audio.
I can hear you just fine.
Okay.
Getting a note from another attendee that he can hear you okay. I don't know who's having trouble with their audio.
Okay.
Yeah, I got another one saying says you're good too, and getting 2 or 3 others. So I don't know where that note's coming from, but I think you're okay.
Okay. All right. Just wanted to be sure. So again, what we've done is we're globally distributed, but every single point for us is a scrubbing center. It does 2 things. One is these attack sizes have increased. It gives us a lot more area on which to deal with it. And 2, from a packet per second standpoint, we have a lot more equipment that can terminate those connections, review them, and then send good traffic on as necessary. Okay. So quick look at what's in our points of presence. What is in our points of presence is we usually have more than 1 transit provider. So that could be any one of the level 3s, the NTTs, the Tatas, and these are the large internet provider, and large telecom providers. The next thing we do is we have 2 switches usually in our environment, and we deal with what we have is a custom appliance called the Behemoth. And they're designed to handle anywhere from about 500 million packets a second all the way north of 1 trillion packets per second. Now, we have what's also called lit and unlit capacity, because one of the things we saw coming was the packet per second rate increasing, because that's the way you overwhelm a lot of hardware appliances. And hardware appliances that you'll typically purchase off the shelf, they have an upper limit of what they can support or what they cannot support. The Behemoth appliance is custom from hardware, basically from metal up, all the way through software. We also have something called sinkholes. So like any other vendor, if we find out that this traffic is just all bad, we're not going to try to terminate it on the endpoint, because then you're still running into the same connection issue. I still have to make the connection, validate it, and then close the connection to dump it. So what we've done is we've created what we call sinkholes. So once we've discovered that this traffic or this IP is completely all bad, we've actually routed over to what we call a sinkhole, and it's purely designed to do exactly that. Take that traffic confirm the connection, and basically throw it on the ground. The combination of these devices in our POPs allows us to, one, handle a huge amount of packets per second, but two, continue on as a mitigation vendor where we're actually inspecting packets, seeing what's good, what's bad, making a determination, and sending traffic on to our customers. Now, I always bring this up when I speak to DDoS customers, is why is this critical? We look at DDoS as a technology event, and it is. And we look at DDoS as a nefarious event where someone is attacking us. But once all the technology is done, then starts all of the legal. And then starts all of the internal corporate processes. So sometimes when we look at a DDoS attack and we say this attack cost the technology part of the company X amount of dollars, what we're missing is the rest of the company and everything that has to happen. Because if your website goes offline, what's the first question most of your customers are asking? Is my information safe? That's a great question. And honestly, if a website that I did shopping on went offline, I would be asking the same question. Is my information safe? Is my credit card information has been stolen? We've heard the reports of this happening. And the reality is sometimes DDoS attacks are a backdrop to really what they really want to go after. And if they can get you focused there, they can go do their thing over there. So a little bit of misdirection magician's work. But the reality is there's a huge cost to any corporation to assure their customers that their information is safe. You're going to lose some customers that may or may not come back ever again. But then you're also saddled with all the legal and compliance requirements of making sure that that customer information is safe for the next. Some countries require 3 years, some countries require 7 years. So even if the customer never shops with you again, you're still responsible for their personal information. And if anything ever happens to it in the future, you then have to deal with that ongoing litigation cost. So the cost of a DDoS attack goes way beyond just what's the technology. And this is the difference between a blocking vendor and a mitigation vendor. Mitigation vendor, your customers continue to be able to get to your website. A blocking vendor, they're going to stop the attack. They're going to protect your technology, but they're not going to protect the rest of your business. I would pause for questions here. I don't know if anything's come into the question and answer section.
The only thing that I see come across, I was going to save it to a little bit later, was how do you protect people that are don't have their websites at their own location, but if their websites are being hosted or their stuff is at Amazon Web Services or Microsoft or things like that?
That's actually a very good question, and because we're in the cloud and essentially Amazon and these other platforms are in the cloud, we're able to protect them as well. If a customer from their desktop needs to get to a device somewhere, we can always handle that traffic, route it through us, and then route it on to those vendors. We do have specifics around that, and I'll have them follow up with you guys directly, and we can always put together a more detailed call. I don't really want to make this a sales call, but I will say that we do have technology to work with those platforms. So those are one of the platforms that we're actually in the process of becoming partners with for that exact reason.
Thank you.
Okay, not a problem. So I've kind of already spoken about this. Having 30 points of presence around the globe gives us a lot of flexibility. It gives us a lot of flexibility for what we call our POPs to work in conjunction with each other as these attacks get bigger. And we do this in region. So similar to the previous model, it's more of a hybrid of the in-region model versus the point of presence model. What we've done is we've created what we call megapops. Now those are the megapops. So our smaller points of presence are typically handling about 500 million packets per second. Our larger points of presence are north of 1 trillion packets a second capable. The reason I say capable is we have not run into an attack where the mitigation capacity of those megapops has, a tenth of it has been used. We have run into attacks where some of our regional or smaller POPs have been used, but the nice thing is we have a routing model where we can bring all of our POPs in line to support customers in attacks. Okay. let's talk about
Lester,
the mitigation.
I do have one more question for you. I'm sorry to interrupt you. There's a question about migrations or mitigation services over load balancers. How do you handle if a customer has different load balancers around the globe to be able to handle their websites? How do you handle the DDoS attacks against those?
Well, we have two, and some of this is just pure architecture. We have customers that want to have a load balancer in front of our mitigation services. It's not always advisable because we don't know the capabilities of that load balancer. Typically, it's similar to any other fashion. We try to put as much of that traffic behind us as possible. So we would be the inbound to that load balancer's VIP. And depending on how many VIPs you have defined and what the routing protocols are, we'll work with you on that. One of the things we offer within the Encapsula Cloud is load balancing. So we're actually able to talk to load balancers and work out who's managing what. The reality is most of our customers start out with a load balancer in front of their data center or in front of their traffic, typically transition that into our cloud load balancer. Because unlike, and you can really just look at it this, a data center load balancer knows what to do with traffic once it gets to it. So it's going to look internally and say, which system should handle this traffic? Our cloud load balancer, we have the advantage of being able to see the traffic from essentially as close to your customer as possible. So because of that, we're actually able to balance traffic all the way through our cloud and into your environment. And if you give us full access into the amount of traffic flow into your particular front-end servers, we're actually able to balance traffic across your front-end servers as well, so that we're not just load balancing your servers from a hardware standpoint, but we're also load balancing or managing what I like to call your customer experience and making sure they have the fastest access possible through our cloud and into your environment. Hopefully that answered that.
Thank you very much.
And just to reiterate on this, being a security-first vendor has given us a lot of advantages in content delivery and distribution. And I want you to take a step back and really think about it. Let's just look at this as an attack, and I'll roll into this slide here. When you're being attacked, and as that attack is changing, and application attacks are very complex, you need someone, or in this case, our operations center. If we need to make adjustments to your particular policy or to our edge policies to handle that type of an attack as it's changing, as it's morphing, as they're actually literally trying to find ways through our protection to get to you, you need a system that can deliver rules quickly. Now, when you think about a distributed attack, that attack can be coming from every part of the globe, and typically they do. So when we deliver a rule out onto our system, it has to get to every point of presence as quickly as possible. So that's one. Now, during an attack, that's a beautiful thing to know that we can deliver rules out. Pretty much one rule, we can deliver a new rule almost every 20 seconds to every point of presence across the globe. When you're not under an attack, having a system that has that capability of passing information back and forth between itself lets us do things like amazing load balancing, lets us do things like content delivery rules, lets us do things like, building ourselves into a caching solution where you can know that you purge a component from our cache and it's purged worldwide. So that communication mechanism is bidirectional. It lets us do a lot of things from security, but as we built out our platform, we found out it let us do a lot of things in a non-security fashion as well. So let me kind of walk through this mitigation flow, and you kind of already understand it. We do packet analysis on the edge, and we have a set of rules there that do their things. The next thing we do is a typical application firewall. So once we've figured out, good, bad packets from, let's say, a layer 2 and layer 3 level, now we're dealing with the packets on a port that you actually want, which let's say typically is 8443, and that port can vary based on the application. Now we have to look at what's coming through, and we have to decide, is this good, or these bad requests? Are these requests based on the agent that we're talking to on the back end? So for example, we're talking to Apache, Magneto, and any one of the other e-commerce platforms. Is this typical string or data that's being sent? Is it a known vulnerability? Let's get rid of that. So we're filtering it down even more. Then we get into what we call DDoS rules engine. DDoS rule engine says, okay, this looks like it's volumetric in nature, but based on the history of this website, it's never seen volume like this. So we can get rid of some of these extra things. So it's, and some of you might be familiar with, in the network world, what's called traffic shaping. We actually do that as well at the application layer. So we've taken that idea of traffic shaping, of these type of protocols and these type of peaks and valleys exist in a standard traffic profile for your customer, and we've done this on an application layer. So we've started traffic shaping what type of requests you get in your application on a regular basis, how many, hills and valleys, similar. So we're actually able to reduce some more of what we think is, you know, nefarious traffic. Then we get on to, we're not sure. We're not sure if this is good, if this is bad, if it's identifying itself, if it's lying to us, and that's when we get into what we call progressive challenges. Progressive challenges are where we find a way to challenge the endpoint and say, or the client, and ask it if it's truly who it is. And based on its responses, we can filter out more traffic. And that's where we get down to that final blue arrow that's really the traffic you're supposed to have for your customers. And since you're only getting the traffic you're supposed to have, you can respond back to that traffic knowing that you're talking to a real customer. Okay. We've kind of gone through this. We support all three of these things, and in some way, if they're important. Security, absolutely, we know what that's about. Performance, I can have all the security in the world, but if I cannot get to it in a timely manner, a customer still considers your website down. As a mitigation vendor, if we can't provide the performance, we've already failed. The same thing for the next one, availability. If I cannot get to your website, it can be secure as possible, but I've already failed.
Lester, I think there's a delay in your slide
Yes.
advancement.
Oh, okay. We'll slow that down
right
a
now
little bit.
we still see the mitigation flow.
Ah. That would be a delay.
They catch up okay, but we're not on that slide yet. I mean, you're welcome to keep
Okay.
talking to it, but
Okay. I'll talk a little bit longer. That might solve some of the issues. So anyway, it just talked about the top operational problems you're thinking about. And from any DDoS perspective and from any DDoS vendor, these are the most critical things. Security is not secondary, but security without the other two simply just doesn't work. And again, being a mitigation vendor, it's not just about mitigating that attack from a technology perspective. It's also about ensuring it doesn't make it in, as I mentioned earlier, into the rest of the organization. And if it does make it into the rest of the organization, how do we support the rest of the organization as they go through their processes? So what we deliver from the cloud, I've kind of already touched on, we've definitely touched on the website security and the DDoS protection. The load balancing and the CDN, these are things that are benefits. And I go back to performance and availability. Having a CDN, and I say this to customers all the time, we're delivering our content directly out of your points of presence. We have larger pipes than you, which means that your customers are getting a better performance. And most importantly, when you're under attack, your customers are getting their content from us. So we can really, truly filter out what needs to go back to your environment and what we can deliver. The whole intent of that purpose is that your customer never feels the attack. Load balancing, it's a beautiful thing. It comes with it. So, quick overview. Different things that we do and how we filter down to the actual web application. Access control. Let's get rid of all the unwanted
Lester, we're still on the mitigation flow slide. I don't know if
you're still on.
Stop sharing
Okay.
and reshare.
That's exactly what I'm about to do. Encapsula security model come up?
Nope, we still see mitigation flow. If you can, you may want to jump out of the PowerPoint and go, unless there's more setup we need to do, go into the actual demonstration.
Let's do that. Yes, let's absolutely do that. So as I mentioned, there's some benefits to being a security-first vendor. What you're looking at is we're able to pull back real-time statistics from all of our 30 points of presence around the globe as they use our solution. So hopefully, I'm hoping at this point everyone has at least gone to our partner's website here, which would be good. And what I'm going to do is I'm essentially just going to start this script. And it's going to start sending traffic towards the website. In the real-time dash bar, you're going to see it's going to take about 30 seconds. And this is an attack mitigation. So this is an application attack, and as you read up about what Hulk does, you'll start to, go through that component and realize that it's varying its traffic types and it's doing a bunch of things in the background. What I'm going to do here is I'm also going to go to the customer site. We're going to let that connect while I'm running. So you'll also notice one of the things we're doing is we're clearing out about, well, we're pretty much blocking about 400% of that traffic right now. And also because I'm running it from my desktop here, I'm going to have to go through a security check. So the other thing I kind of didn't point out is that one of the parts of the Incapsula solution is we look at things session by session. So if you think about the anatomy of an attack, I'm not necessarily taking over someone's entire machine. I might be just taking over part of it. Or if I'm sitting behind a proxy, there might be 10 bad sessions and there might be 1 good session. So here I'm going to basically go through a check. And it's asking me to put in my CAPTCHA here. So, and I want you to really think about what you're seeing here. I'm attacking this website from this machine. So that's happening on one of the sessions that I'm using. But my other session has actually been filtered out, and I'm now actually able to get to the customer's website. And apparently my machine's a little slow today.
Yeah, I said WebEx. I apologize to all WebEx users. It's GoToMeeting. There we go. Now we got live traffic coming through. Now it's looking good.
Okay, so guys, if you were browsing the website over the last 30 seconds while we did not have video, and you look at that red line, that is how much bad traffic I sent towards this website. And you can see it kind of peaked up somewhere around almost 250 packets requests per second, which is a little different from packets per second because this is an application level attack. So packets per second were much higher than requests per second if you think about an HTTP request. That's what's been going on for the last 2 minutes, and I've been running that essentially from my desktop here over to the site. So hopefully you guys have been browsing it. Now that I have the screen up for you, I'm kind of really not moving it.
Oh, and just so you know, I got to talk to my security team because I just got notified that we're being attacked. It's been 2 minutes, so I got to talk to my security team. But I got a notification that we're being attacked.
So guys, we're protecting our partner site. We use that in this demonstration. It sounds strange to say this, but we're going to provide you the URL to Hulk. I wouldn't say just push this against our partner's website here, but this is the idea behind what Incapsula is from a mitigation vendor. You can browse the site that's being attacked. You can browse your site that's being attacked. And all of the legal processes and compliance processes and governance processes, they may still kick in from an internal standpoint, as we've noticed he's got to go tell a security team that, hey, that was us. But most importantly, it doesn't affect your customers. The attack is still ongoing, by the way. So I'm going to kind of open it up for questions because I don't really want to move GoToMeeting around too much at this point in time.
So one question that had come through, I guess, still on the Amazon Web Services and Microsoft, do they not provide a DDoS protection already? I mean, is that not part of the service that you pay for?
So volumetric, most vendors, and I want to be clear, so Incapsula, so I got this question yesterday, I actually get this question a lot. We actually protect telecom vendors. When we started out in this industry, we were protecting telecom vendors, and at that point in time, most telecom vendors had protection up to about 4 gigabits per second. Now they might be running 6 to 8 gigabits per second, but anything beyond that, you're in trouble. Now that's purely volumetric network DDoS attack traffic. application traffic, they don't know what your application is good for or what your application is not good for. So they don't necessarily understand your application traffic. And when you think about AWS, Azure, Google, these are all application service providers at the end of the day. So they're going to try to open up as fast a port to your application as possible. Now, they're also businesses, so let's be clear. If you get attacked at the application layer like just took place here, the only thing they're going to do is charge you for more bandwidth. And you might design your application to scale out, and then your application has to filter that good and that bad out. Or you come to a vendor like us, and we stand in front of your traffic, do that filtering, as I mentioned before, the mitigation, and then allow your application to only get application traffic that it needs to get. I don't want to say, it's the way that these providers have been designed. And again, volumetric attacks, I think, have gotten a lot more press than application attacks, and they're completely different in the way in which they're leveraged against your sites. And again, that person seems like we need to, and I'm talking very nebulous because we are on an open call, and security is one of those things where we don't really want to dig into details on any one particular site, particularly in public. So I would please recommend that you get in touch with NCSI, and we'll follow up with them, and we will definitely have a detailed conversation with you about what you're running in that environment and how we can protect you, or what your threats are that you need to look out for, so you can make determinations about what you need to do. But again, we protect several customers in those environments today because of exactly this conversation we're having.
Cool. Well, thank you for answering the questions. I don't have any other questions that have come up online right here. So Lester, I want to tell you thank you for your time. I think the presentation was great. I can tell you our website is up and running, and it's even when it's under attack. That, as we mentioned at the very beginning, is the difference between a blocking vendor and a mitigation vendor. The fact that we can still provide service to our clients, still provide that information, is fantastic, even in the middle of an attack. This is exactly what the clients need. So appreciate your time. We have no more questions, and so we'll wrap up the webinar. Again, thank you everyone for attending.
Thank you.
Thank you.